Something started going wrong with this grow, and honestly, if I was only looking at the plants, I probably wouldn't have realized how far things had gone. Most of the canopy still looked pretty healthy, the flowers were developing, plants were growing, and there wasn't anything that immediately screamed a major nutrient problem. But then I tested my runoff. The strawberry banana was around 3.6 EC, two of the Humboldt dreams were approaching 4.0, and our most stressed Humboldt dream peaked at around 4.4. That told me the nutrient concentration in the root zone had gotten much higher than I wanted. So today, I'm going to show you what happened, what I think caused it, how I corrected it without immediately lowering my nutrient strength, and most importantly, how the plants have responded since. And, interestingly enough, one of you actually helped me catch it. Welcome back to the Cannabis Classroom. Before we get into everything, I want to thank everyone who says subscribe, like the videos, and especially those of you leaving the comments. There's actually one comment from the episode before last that I specifically wanted to mention. One of you pointed out that these plants weren't praying as much as you would normally expect from really happy, vigorously growing plants. Now I want to be careful here because leaf angle by itself doesn't diagnose a nutrient problem. Plants can raise and lower their leaves because of lighting, watering, genetics, temperature, humidity, their natural day and night rhythm, a lot of different things. But that comment made me stop and look at these plants a little more critically. And once I did, I decided to check my runoff. That's when I realized we had a problem developing underneath the surface. So who left that comment? Thank you. You didn't diagnose the problem from a YouTube video, but you gave me another reason to investigate, and that helped me catch this before it potentially became a much bigger issue. And that's exactly why I want you guys participating in these grows. If you notice something, tell me. If you've got an idea, leave it in the comments. I've been growing for years and I'm still learning something new every grow. And that's what the Cannabis Classroom is supposed to be about. So let's talk about what I found. As you guys know, I'm growing these plants in roughly 70% Coco, 30% perlite. And Coco behaves very differently from a traditionally amended soil. I'm supplying essentially all of the mineral nutrition these plants need through my nutrient solution. That gives me a tremendous amount of control, but it also means irrigation management becomes extremely important. I had been feeding these girls consistently, and on the surface, everything seemed pretty good. The problem was that these girls had gotten a lot bigger. Their root systems had developed, the canopy had exploded, and their water demand had increased dramatically. But while the plants had changed, my irrigation volume hadn't changed enough with them. I was still getting some runoff, but apparently I wasn't moving enough fresh nutrient solution through these pots to keep the root zone concentration where I wanted it. And over repeated irrigations, that concentration started climbing. Eventually, the runoff numbers showed me just how far it had gone. Before we go any further, you'll probably notice I'm using EC instead of ppm in this video. Up until now, I've normally talked about ppm because that's what I've gotten used to reading on my meter. But there's a problem with ppm. Two growers can measure the exact same solution and get different ppm numbers depending on the conversion scale their meter uses. EC gives us a standardized measurement of the solution's electrical conductivity, so it's much easier to compare numbers between different growers and different meters. So for anybody who's more familiar with ppm, the highest 4.4 EC reading would be around 2,200 ppm on a 500 scale. But from this point forward, I'm going to primarily use EC on this channel. It's more universal, and especially since we're growing in Coco, I think it's the better measurement for what we're trying to learn. Now here's probably the most important part of this entire video. When I saw those runoff numbers, I didn't immediately slash the nutrient concentration. Instead, I changed the volume. And that's a really important distinction between nutrient strength and irrigation volume. The concentration of the solution I'm putting into the pot is one variable. How much of the solution I actually put through the pot is another. My concern wasn't simply that I had been mixing an insanely strong nutrient solution, The bigger issue appeared to be that I wasn't putting enough solution through these increasingly large plants to adequately manage the concentration building in the root zone. So rather than immediately changing everything these plants were receiving, I kept my nutrient solution at approximately the same strength and substantially increased the volume of solution going through each pot. That meant considerably more runoff coming out the bottom. The idea was to move more fresh nutrient solution through the cocoa and bring that accumulated concentration back down. And then I measured again. That's important. Don't make a correction and just assumed it worked. Look at the data afterwards. Over the next few irrigations, those runoff EC readings started coming down. It started at 2,000, then I got 1,800, then I got 1,600, and now we're averaging approximately 1.9 EC across all plants. That's a massive difference from the 3.6 to 4.4 EC I was seeing at the peak. And again, to compare those to the ppm measurements I just gave, that was starting out at the EC of about 4.4 and coming down to that EC of 1.9. Here's probably the biggest lesson I learned from this entire situation. Nutrient strength and irrigation volume are two completely different things. When I first saw a runoff EC of over 4.0, it would have been easy to immediately think, I'm feeding way too strong, we need to cut these nutrients. But that doesn't necessarily identify why the root zone became so concentrated in the first place. In my case, the plants had gotten significantly larger without a proportional increase in the amount of solution I was putting through their containers. So instead of immediately starving flowering plants of nutrition, I first addressed what I believe was the underlying irrigation problem. I kept the input concentration approximately consistent and increased the volume instead. And that's when the runoff EC started falling. That's why I think runoff can be such a useful diagnostic tool when you're growing in cocoa. But I also don't want anyone watching to think that the 1.9 EC runoff is some magical target, or that one high runoff measurement automatically proves nutrient toxicity. Runoff measurements can be affected by your irrigation volume, dryback, sampling, and several other factors. What concerned me was the trend, how high the runoff had climbed relative to my input, and the symptoms I was beginning to see on the plants. The number wasn't the entire diagnosis, it was just another piece of evidence. Since we're talking about the nutrient strength, let me show you exactly what these plants are receiving right now. I'm still running the Athena nutrient program along with silica and CalMag. And throughout this correction, I kept the nutrient solution the same. The major change was simply giving each plant more volume and producing more runoff. And I'll put my current nutrient recipe, input EC, and pH on the screen so you guys can see exactly what I'm running. My silica, I'm running about 2 milliliters per gallon. CalMag, also about 2 milliliters per gallon. 2 grams of Athena Core per gallon. And of course, since we're out of that vegetative state, we're not using any Athena Grow. And then our Athena Bloom is 4 grams per gallon, giving us an input EC of about 1.9 to 2.0 and a pH of about 5.8. That's where I like to keep it since we're growing in cocoa. One thing I want to make clear though, I'm showing you these numbers because I want this grow documented. I'm not telling you to blindly copy them. Your genetics, water source, environment, plant size, irrigation frequency, and growing conditions can all change what your plants need. And these have obviously been changing throughout the whole grow for me. Use your numbers as tools, don't let them replace actually watching your plants. While I've been working on what's happening underneath the cocoa, I've also been fighting another problem above it: humidity. And just look at these plants. There's a tremendous amount of foliage packed into this 4x4. Every one of these leaves is transpiring water. The roots absorb water, it moves through the plant, and eventually a large portion of that water leaves through the stomatas in the leaves and enters the tent as water vapor. And now that I'm increasing the amount of irrigation these plants receive, I'm putting even more water into this system. With 4 plants this size inside a relatively small space, that's a lot of moisture to manage. And humidity becomes increasingly important as we get farther into flower. As these flowers get larger and denser, the last thing I want is stagnant, humid air trapped inside this canopy. So I decided to go back in for another selective defoliation. If you watched the last episode, you know we already did our biggest major defoliation and training session. And I'm not trying to completely strip these plants again. This pass has a slightly different purpose. I'm looking for areas where large fan leaves have grown back into one another. I'm looking for extremely dense areas in the middle of the canopy. And I'm looking for leaves that are restricting airflow around developing flowers. Opening some of these areas gives air more room to move through the plants. Reducing some of that leaf area can also reduce the overall transpiration load somewhat. But I want to make an important distinction here. Defoliation isn't a replacement for proper environmental control. I'm not going to solve a seriously humid grow room with a pair of pruning shears. My dehumidifier, exhaust system, and circulation fans still have to do the heavy lifting. I'm simply trying to create a canopy that allows those systems to work more effectively. And because these are autoflowers, I'm still being conservative. Every leaf I remove needs to have a reason. Now let's look at how each girl handled this individually, starting with our strawberry banana. Honestly, she looks like the healthiest plant in the tent right now. And interestingly enough, she also had the lowest peak runoff EC. She still reached approximately 3.6 EC, so things certainly weren't where I wanted them, but she never climbed quite as high as the Humboldt Dreams. My theory is that her smaller size actually helped her in this case. She's the smallest plant in the tent, but she was receiving roughly the same irrigation treatment. That meant she was getting proportionally more solution relative to her demand and consistently producing more runoff than the larger Humboldt Dreams. That may have helped prevent the root zone from becoming quite as concentrated. You can see just a little bit of burning on some of the very tips of the leaves, but overall, she stayed remarkably healthy. Her color looks good, she's been developing flowers nicely, and structurally, I'm really happy with her. So even though the 3.6 EC runoff told me things weren't ideal, she seems to have handled the situation better than most of the tent. Next up is our first Humboldt Dream. And you'll notice something that we're going to see to varying degrees on all 3 of these girls: burnt tips. Leaf tip burn can have several causes, so I don't want to look at one burnt tip and immediately claim nutrient toxicity. But when I combine that with what I'm seeing on the leaves with what I measured in the runoff, excessive root zone nutrient concentration becomes a pretty reasonable concern. This girl's runoff reached approximately 4.0 EC at that peak, and this is one of the reasons I think monitoring runoff is so valuable in cocoa. If I had only looked at this plant, I could have easily said, it's just a little tip burn, she looks fine. And overall, she did look pretty good. But that 4.0 runoff gave me another piece of information. Something underneath the surface was trending in a direction I didn't like. And I'd much rather catch that now than wait until the plants develop much more serious problems. Then we got our Humboldt Dream number 2. This girl has actually been surprisingly resilient. Her runoff also reached approximately 4.0, but she maintained a really dense, healthy looking canopy through most of it. She's held on to good color, she's continually developing flowers, and overall, she didn't outwardly show nearly as much stress as her sister. And I think that's another important lesson from this grow. Plants don't always respond identically. These 3 Humboldt Dreams came from the same strain. We're growing them in the same tent. They're receiving essentially the same environment and treatment, and yet we're still seeing differences in how each individual plant responds. And that's part of growing for seed. Even with the same genetics, individual phenotypes can express themselves differently. And so far, number 2 seems to be pretty resilient. And finally, we've got our Humboldt Dream number 3. If you've been following this series, you already know this girl has had her fair share of stress. She started out behind the others, she's dealt with a couple of setbacks, and this time she definitely showed me clearly that something wasn't right. She began to struggle. Her color was fading, we were starting to see more yellow, and she simply didn't look as happy and healthy as her sisters. And then I tested her runoff. 4.4. The highest reading in the entire tent. And suddenly the symptoms I was seeing made a lot more sense. Again, I'm not saying one runoff reading proves exactly what was happening around every root, but now I had multiple pieces of evidence pointing in the same direction. I had visible stress, I had yellowing, and I had some tip burn. And I had an extremely elevated runoff EC. So I increased the irrigation volume, moved more solution through the pots, and started bringing that concentration back down. Now she's around 1.9, and honestly, she's already looking noticeably happier. Her posture has improved, she looks healthier, and she seems to be responding well to the correction. Considering everything this girl has been through during this grow, I'm pretty happy seeing her bounce back. And I'm seeing improvements across the entire tent. At their peak, these plants range from approximately 3.6 to 4.4 EC, and after increasing my irrigation volume and continuing to monitor them, we're averaging around 1.9 now. But that number isn't the only thing I'm looking at. I'm looking at the plants. And remember that comment I mentioned at the beginning of the video? Take a look at some of those tops now. We're starting to see more of the leaf stretching upward again, seeing more of that praying posture. And no, praying leaves aren't some definitive test that tells me everything is perfect, but when I combine that improved posture with the reduction in runoff EC and the overall appearance of the plants, I'm hopeful we're moving in the right direction. And now I think the smartest thing I can do is not overcorrect. I made the adjustment, the numbers have responded, the plants appear to be responding. Now I need to just give them some time. This entire situation reinforced something I think is really important. Don't wait until there's a disaster to start asking questions. If I hadn't checked my runoff, I could have continued doing exactly what I was doing. The strawberry banana looked healthy, 2 of the Humboldt dreams were still growing well, the flowers were developing, and from across the room, I could have looked at this tent and thought everything was fine. But there were little clues, some burnt tips, some yellowing, leaf posture that wasn't quite as vigorous, and then the runoff EC gave me another piece of the puzzle. And that's the skill I'm trying to improve as a grower, not waiting until the plant is screaming at me that something is wrong. Learning to notice when it's just starting to whisper. So that's where we're at with this grow. We've brought that runoff EC down dramatically. The plants seem happier. We've opened the canopy back up to help improve airflow and manage some of that humidity. And now I'm going to continue to monitor the root zone while these girls put more and more of their energy into flower production. And I want to say thank you again to the subscriber who originally commented about the leaf posture. That's exactly what I want the cannabis classroom to become. If you notice something I'm missing, tell me. If you agree with something I'm doing, tell me why. And if you've dealt with rising root zone EC and Coco before, I'd especially like to hear how you handled it. There are 100 different ways to grow this plant, and I'm never going to pretend mine is the only one. We're here to learn from the plants and from each other. So if you're enjoying the seed to harvest, hit that like button and subscribe because we're getting into the part of the grow I've really been waiting for. These flowers are starting to stack, we're beginning to see what these genetics can really do, and we've still got plenty to learn before harvest. Thank you guys for watching, and until next time, class dismissed.